Welcome back, everyone, to our continued discussion of classification performance metrics. In part 2, we'll be discussing precision and recall. We already know how to calculate accuracy and its associated paradox in the case of imbalanced classes. Let's now explore 3 more classification metrics that can help give a clearer picture of performance. And those are recall, otherwise known as sensitivity, precision, and then an F1 score, which essentially combines recall and precision. Let's begin with recall. Recall answers the question, when it actually is a positive case, how often is it correct? That is to say, when a person actually is infected, how often is the model able to correctly identify that this person is infected? And this is calculated by taking the number of true positives and dividing it by the total number of actual positives. So if we take a look at our original confusion matrix, we can see that underneath the actual infected column, we have a total of 4 plus 1 for 5 people. That is, 5 people in the dataset were actually infected. And we want to know, in regards to recall, when they're actually a positive case, in this case infected, how often are we able to correctly identify them? And that is true positives. So 4 divided by 5 results in a recall of 0.8. Another way of describing what recall is the ability to answer the question, how many relevant cases are found? So you could say 80% of the time we find the relevant case. Relevant being that this person is actually infected and we are able to predict that they are infected. So let's imagine back to the issue, if we always classify someone as healthy, what would the recall actually be? You can remember that in the previous lecture, we saw that accuracy showed up as 95%, even though we always said someone was healthy. But let's explore what happens to recall in this case. Recall in this case would be 0 divided by 5, which is essentially 0. So a recall of 0 alerts you to the fact that the model is not catching any relevant cases. So that's what is going to alert you to the fact that you have a model that's completely overfit and doing something like reporting everything back to the majority class. Now let's explore the metric called precision. Precision answers the question, when the prediction is positive, how often is it correct? And the way we calculate this is by taking the number of true positives and dividing it by the total number of predicted positives. So we can see here along the predicted row, we have 6 people that we predicted were infected. So then the denominator becomes 6. However, the true positives, that is, how often we got it correct, is 4. So that means our precision is 4 divided by 6, or 0.666. Let's now refer to the fact that what happens if we always classify something as healthy? Again, an incorrect model, always predicting the majority class. In this case, you would get 0 over 0, or basically precision being undefined. So this would also alert you to the fact that there's something wrong with your model, always predicting the majority class. We can see here that recall and precision do not fall to the accuracy paradox. So recall and precision can help illuminate our performance specifically in regards to the relevant or positive case. It allows you to know how well you're doing at actually identifying that relevant case. And depending on the model you're using, there's typically a trade-off between precision and recall, which we're going to be exploring later on with something known as the ROC, or Receiver Operator Characteristic Curve. Now let's finally discuss the F1 score, otherwise known as the F metric or F score. Since precision and recall are related to each other through the numerator, recall that's the true positive, we also want to often report the F1 score, which is the harmonic mean of the precision and recall. We use the harmonic mean instead of the normal mean because this allows the entire harmonic mean to go to 0 if either precision or recall ends up being 0. So essentially what F1 score wants to do is report back to you how well you're doing in both precision and recall in one number. But if you were to take the average of precision and recall, if one of those was 0, you could still get a number for F1 score. What we want to do is, in the case that we get either a 0 recall or 0 precision, we want the F1 score to also be 0, which is why we use the harmonic mean, which if you take a look here, we would get 2 times precision times recall. So if either precision or recall happen to be 0, the whole thing would go to 0. So it instantly alerts you to the fact that if you just see F1 score being equal to 0, that means either precision or recall is 0, or they're both 0. Now, as a final note on the confusion matrix, there's actually many more metrics available than just recall, precision, and accuracy. And you can check out the Wikipedia page for many other metrics, all stemming from the confusion matrix. Things like positive likelihood ratio, negative predictive value, etc. And many of these are used in the medical field. However, for our discussions on machine learning, we should be fine with just understanding accuracy, precision, recall, and then the blending of precision and recall through the F1 score. The last thing we're going to explore in regards to classification metrics is a way to visualize the relationships between the metrics, such as precision and recall, with curves. I'll see you at the next lecture where we discuss ROC curves.